1 by Rp is equal to n times of 1 by R. That means n by R. And since 1 by Rp is equal to n by R, we could write Rp is equal to R by n. This is the formula that we have to remember in parallel combination. And if you are comparing with the series combination and parallel combination, you could clearly see in series combination the total resistance is increasing. In series combination, the total effective resistance is increasing. And in parallel combination, you could see the total resistance is decreasing. Okay, in series combination, the net effective resistance is increasing, and in parallel combination, it is decreasing. Then we could say one more relation, that is, if there is n resistors connected in parallel, let's say this is our R resistor and there is another resistor. Likewise, many resistors are connected in parallel. Let's say the current across each resistor, let me call it as I dash. The current across each resistor is I dash, means we could write, by using this relation, I could write the total current is equal to I dash plus I dash plus I dash, that is n times I dash. That means I could get I dash is equal to I by n. This is also an important relation that we could use in problem solving. Okay, therefore this is regarding series, the parallel combination. Now we know about series combination of resistor and parallel combination of resistor. Let's move on to our next topic. Okay, now we will discuss a problem which is having series combination and parallel combination. For defining that problem, let me draw a circuit. For you. We are having many resistors. Let's say this is one resistor, second, third. Let's add one resistor over here also. Now we are having a circuit like this. Let's have a circuit like this, and for our sake of simplification, let's use all the resistors as 2 ohm. 2 2 2 2 2 2 2 and 2. All the resistors are of 2 ohm, and they are asking you to find out the effective resistance between A and B. These are the two terminals. They are asking you to find out the effective resistance between A and B. On solving the effective resistance between A and C, we will say this is a simple circuit. You might ask me, if it is simple circuit, why this much resistors? Yeah, there are a lot of resistors over here, but this is a simple circuit. That's it. It is an easily identifiable circuit. Okay, then we will have to look for the series combination in this. Which all resistors are in series combination? If you are analyzing these two resistors, are they in series? No, they are not in series, because there is a connection over here and there is a connection wire going between these two. Therefore we cannot say this is series. Okay, then let's look at the two resistors over here. These two resistors. Now the current passing through this wire should be equal to current passing through this wire. As we have learned, in series combination the current will be same. Therefore I could easily say the current passing through this 2 ohm resistor will be equal to the current passing through this 2 ohm resistor. Is that clear? Then I could say these two are in series. If they are in series, what I can say is, instead of these two 2 ohm resistors, I could directly draw a 4 ohm resistor over here. A 4 ohm resistor over here. Therefore, let me try to delete all these wires. Instead of that 2 ohm resistors, we are having a 4 ohm resistor. Clear? Then we will look at other series combination. Is there any more series? Let this is also 2 ohm resistor. Okay, then is there any more series combination? Can we say these two are in series? No, they are not in series, because the current flowing through this wire won't be equal to current flowing through this wire, since we are having a branch over here. Therefore they cannot be regarded as series. Then let's look for the parallel combination. Let's look for the parallel combination. Then for parallel combination, what's the simple thing? The potential difference across the two resistors should be same. Then they are in parallel combination. In that sense, if we are looking at these two resistors, they are parallel, because the potential across this resistor, the potential difference across this resistor is exactly equal to the potential difference across this resistor. Therefore these two are parallel. If they are parallel, we have learned in parallel combination identical resistors, it is Rp is equal to R by N. In parallel combination identical resistor, it is Rp is equal to R by N. Therefore this is identical resistors in parallel. Therefore it should be R by 2, that is 2 by 2, that is equal to 1. R by 2, that is 2 by 2, that is equal to 1. Therefore instead of these two resistors, I could directly draw a 2 ohm resistor over here. I could directly draw a 2 ohm resistor over here. It's not 2 ohm resistor, it is 2 by 2, that is 1 ohm resistor over here. Then let me rub this wire and I redraw the circuit. Okay, let me try to rub this wire. Yeah, this is gone. This is also gone. This wire is gone. Then let me delete this also. Instead of that 2 ohm resistor, let me complete the circuit diagram. Therefore we were having, or we should add a 1 ohm resistor. Okay, a 1 ohm resistor is replaced by these two ohm resistors. Then you could clearly see now these three resistors, they are in what? Series. They are in series. And if they are in series, the effective resistance will be 2 plus 2 plus 1, that is 5. Therefore let me rub all these resistors, these wires, and I'm replacing it with a single wire over here. Over this wire, I could replace a 5 ohm resistor. Okay, then look at these two resistors. They are also parallel, since the potential difference across these two terminals will be equal to potential difference across these two terminals. Therefore these two are parallel. If they are parallel, we could use 1 by Rp is equal to 1 by R1 plus 1 by R2, that is R1 plus R2 divided by R1 R2 what? 1 by Rp. And I could write Rp is equal to R1 R2 divided by R1 plus R2. We could use this expression if there are two resistors directly. Okay, therefore remember this expression also. Then instead of R1 R2, it is 2 into 4, 2 into 4, 2 4s are 8, divided by R1 plus R2 is 2 plus 4, that is 6, 8 by 6, that is 4 by 3. Okay, therefore I will have to replace a resistor of 4 by 3 over here. Then let me rub this. I am rubbing all these things. Therefore we could replace this 2 ohm resistor is already over here, and we could replace the resistor by a resistor which is 4 by 3. Okay, now this 4 by 3 and 2, they are in series. If they are in series, the effective resistance, it should be, let me do it over here, Rs is equal to R1 plus R2, 2 plus 4 by 3, that is 6 plus 4 by 3, isn't it correct? Then 10 by 3. Okay, therefore I could replace these two resistors by a single resistor, which is what? 10 by 3. No need of taking reciprocal since it is Rs. Okay, then this circuit will become like this, and we will have a 10 by 3 resistor over here. Then this 10 by 3 and 5 ohm, they are in parallel. Therefore I could write, I am writing 1 by rp is equal to 1 by r1 plus 1 by r2. That means 1 by 5 plus 1 by 10 by 3 means it is 3 by 10. I could take the reciprocal. Then it will become what? We could replace this by 2 by 10 plus 3 by 10. Then 2 plus 3 is 5. 5 by 10. 5 by 10 is what? It is 10 by 5. That is 1, not 10 by 5. It is 1 by 2. That is 1 by rp is equal to 1 by 2. Ultimately we are getting 2. Okay, did you understand this? Therefore, we could replace this whole circuit by a 2 ohm resistor. Therefore, the effective resistance between A and B, it is 2 ohm. Clear?